Fox Tools is my name, and Meatloaf is my game. For those of you that are new to the channel, I'm Tom, the host, and Meatloaf is a mixed bag, collection of kind of engineering and science related subjects. Sometimes there's machining content and sometimes there's not. Today we got a bunch of cool instruments to look at, a couple of cool books, some pretty neat stuff. So there's usually something for everybody in here, and it's usually pretty entertaining. The troops really like it, so let's check it out. Alright, this next one is a kind of a combined eBay acquisition, show and tell, and a public service announcement, I guess I would call it. So what we got here is we got some gauge blocks here, right? These are square or Hoke, H-O-K-E type. Those are, I kind of prefer these myself. I like this style, although I have both. And then we got a little piece of granite here, we got this guy here, and then we got some precision flat stones here. So where do I start? Let's take a look at this thing first. So this is the thing I got off eBay here, and actually a viewer turned me on to this. He saw the listing and it was mislisted, and then he pointed me at it, and then I bid on it and got it. And I don't quite remember what I paid for it, so there were some other bidders, so I apologize if I outbid you. But so what this is this is a gauge block stone, okay? And it's very special. It's serrated, it's made out of a particular material, and it's lapped extremely flat, okay? And it works and behaves similar, notice I'm using that word, to the precision flat stones, okay? The difference is it's a lot flatter, okay? And it's appropriate for deburring and kind of reconditioning gauge blocks. So you can rub your gauge blocks on here if they don't want to ring together anymore. Which is common. They get little nicks and burrs and asperities on them that you got to do something with. In fact, you see this black stuff on here is stuff that's coming off of this gauge block, right? So give it a little rub there. Okay, and now these are, I picked these because they're not in very good shape. These are just some that I got with a beater set, and you know, and I picked those on purpose. Now this is a similar thing here to this, but it's made by Dual, and this is a gauge block stone here, although the label's missing off of it, or it came off. And you do the same thing with this, right? You basically rub your gauge blocks on here and knock off those asperities. Now, that's precisely the function of precision flat stones too, is they're nice and flat, and that's what they do, and that's why they work so well, is they knock off these little up stickers and shear everything off nice and flush. However, these are not as flat as this, and now this is me talking, this is Tom, you know, and I've heard some comments about this and seen some things on the web where people are recommending that you, or saying it's okay to do your gauge blocks on precision flat stones. So it just kind of depends what you're doing. My recommendation is that you don't do it. You get something like this or something like this that's designed for that purpose. These are designed for a similar purpose, but they're just not as flat. And so the public service announcement is, I wouldn't do your gauge blocks on flat stones, okay? So other ground flat, these are just done on the surface grinder typically. Now mine happen to be lapped, but the commercially available ones are just double disc ground or they're diamond ground. They're not as flat as a gauge block, okay? So what you really want to be doing is rubbing your gauge block on something that's as flat as a gauge block, okay? That's the idea, and that's what makes it work. So these are just not as flat, okay? They have little ripples in them and bumps and whatnot, and you would probably, if you did it aggressively or frequently or whatever, you would compromise your precision measuring gauges. So anyway, let's forget that, okay? Let's quit talking about that. And but anyway, this is a gauge block stone, and the idea is that when your gauge blocks cease to ring, like as so, right? Yeah, it's not even ringing. So that's, well, this is going to be a miracle if we can make this thing ring. So let's give it a try here. Let's give it a good once over here, and I got a little bit of pressure on this, and this is on some foam here so that it can kind of seek a center here. And you notice I'm coming off of the edge and kind of using the whole stone there and polluting it nicely. All right, let's give it a skin wipe. Let's see if we can make this ring now. Maybe. Yeah. That one's probably too far gone. Let's try it again here. Let's give it a little more. Oh, actually, I should probably do this one too here. Let's do that side. All right. I think it was that side, wasn't it? Oh, crap, I don't remember now. Oh well. Yeah, it's not going to go. You can kind of feel it, that it's not going to go. Yeah, I think these are a little too far gone. I don't think it's not a hard ring, but okay, it wasn't too bad. Okay. Anyway, well, you can see that it kind of works, even with some that are not in very good shape. So, so gauge block stone. This is made by Starrett. Unfortunately, they don't give these away. They're pretty expensive. There's two varieties. I do not remember this material here on this one. I don't know if it's borazon or something else, some kind of ceramic. So, okay. This next one's kind of cool. This comes all the way from Germany, and this comes from a gentleman named Stefan Knorr in Berlin. And the story was that he bought some Lista cabinets, you know, the cabinets with drawers, right? And I guess they had a bunch of stuff in the Lista cabinets. He bought it at auction, and the bottom drawers of the Lista cabinets apparently had about 30 of these in them, or I don't know how many, 20 or 30 of them. And he wanted to send some to some of the YouTube creators in the United States, but you know, sending all these individual packages was kind of daunting. So he asked me if I would be willing to kind of forward these on to some of the other YouTube creators, and I said, yeah, sure, no problem, I'll help you out. And he did. So this giant box shows up, and I could barely lift it. It was so heavy. And I don't know what that cost, but Stefan, thank you very much. And so I've already sent out the other ones of these, and you may have seen them on some of the other channels or the Instagram if you follow some of the Instagram accounts. And what this is, let's see if I can pull it out of here without dropping it on the deck here. Let's get this out of here. So what we have here is it's a magnetic transfer block, okay, but it's for setting. You can set angles with it, right? So we can put something on it like this, right? And we can set it up at an angle. Well, that's not going to work, but anyway, you get the idea, right? Is that you can, if we wanted to put a chamfer on that, for example, you could set that up in the surface grinder on the magnet, and clamp that down, and then go ahead and grind that angle that is displayed here on the end, right? Now, there's a couple manufacturers of these, and these particular ones here are, it's Sandox or whatever, and you know, it's some offshore thing, but it's well made actually, I'd have to say. I haven't cleaned this one yet, or kind of lapped it in, but it's actually quite nice. And so Stefan, thank you very much for sending that along. And I'm going to clean this up and put it to use. Now, one thing you can do too, there's another version of this made by a different company. What they have is they have a couple of pins that are located at a known distance, so you can actually use it kind of like a sign. You can use these two pins and stack blocks up underneath them, or spacers, to create an angle and use the sign bar principle. So if you have one of these, you can kind of do that, add that on. So okay, so that's the magnetic block. Now he sent me something else, his little bonus gift here, and we're going to take a look at that next. So what we got here is this, and so. It didn't. I didn't recognize this when I opened it up, and then it took me a minute to figure out how to open it. You know, this appears to be a pull on me kind of a button, but that's not the case. What you do is you push on that. It took me a minute to figure it out, and so what is it? What the heck is it? So. According to the side here, this is a brake efficiency indicator. It's got some British patent here. It's made by Small and Parks, P-A-R-K-E-S Limited, Manchester. And basically it's a little curved bubble level. And what I think this is to hang it up on some bracket or something like that somehow. And so what I don't know is, I got to believe that you hang it up on some bracket and then you move this and you zero it, right? I'm trying to. So that bubble's got some inertia in that fluid or whatever. So somehow you translate this into, and it's got numbers on it, but I don't know what those numbers indicate, right? You know, horsepower or foot-pounds or newtons or I don't know what. And then there's another scale on this side here that doesn't make any sense at all. So if somebody out there kind of knows how you use these, that would be great. I did a little bit of poking around and I couldn't find anything on this, although I did see some something similar for you know, checking the attitude of a Jeep, you know, that's going off-road or something like that, or four-wheel drive that's going off-road. You know, you can look at your angle of the dangle there. So I'm assuming it's some kind of inertial thing, right, where you jam the brakes on and then you're looking at where the bubble's reading, and then you get some kind of insight or relative measurement, you know, as you adjust the brakes or you know, change the brake shoes or improve the braking system or something. I don't know. It's a little pocket thing that came in a nice, cool little velvet-lined box, right? And like I've said before, things that come in velvet-lined boxes are usually kind of fun. So, so Stefan, thanks for sending that along. Maybe one of the viewers out there will school me on how to use this properly, and maybe we can go for a ride in the car and jam the brakes on and see how it works. So anyway, thank you so much for sending all this stuff. I know that was an expensive package to ship just because of the weight, and I really appreciate it, and so do the other YouTubers. Thank you. Well, it's that time of year again. My buddy Phil Kerner sent me one of his new calendars that he's got out, and Phil has been doing these and I think he even calls them these boutique calendars about manufacturing and the trades for, I don't know, 5 or 6 years now, I think. But anyway, he sends me one every year, and they're always just wonderful to look at. And I got some flags on here. We're gonna look at a couple things on here. And if you want one of these calendars, you can contact Phil. There's a link in the description. You can go check it out and buy a calendar if you want, and help Uncle Phil out. So there's the man himself and his wife Heidi. And he wants to sell lots of calendars because Heidi needs some new shoes. So I'm just teasing, okay? So Phil's kind of a serious guy, so I got to be a little bit careful here, okay? So anyway, I'm not going to show you all of them. I've got, otherwise I'd spoil the calendar for you. I got some flags here. So this one caught my attention here, and because it's kind of a trippy setup here. And it says checking a 24-degree angle. So I would say that that is not the case in this picture. I would say that he is setting a 24-degree angle, just by the nature of what he's got in here. And my clue is that there's no angle here, and it looks like he's going to cut this angle. So this makes sense, and he's got a 20-degree block in here and a 4-degree block here, and he's indicating this and getting it set at 24 degrees so he can cut that. Okay, that would be my guess. Now, Phil, correct me if I got that wrong. Now, this is a cool little setup here, and there's a couple of interesting things here too. So this is a vise, and you know what? I think Phil built this vise, okay, because it's got his characteristic painting of the of some of the non-precision surfaces there, and there's a couple interesting things to note here, right? So it's got a nice lead screw. He's milled a hex on there so that you can put a spinner or a socket on there or something like that. And then I caught this. There's the nut, and this looks like an Acme if I had to guess looking at it. But there's the nut, and it looks like there's a little tiny split in there, and then you've got a retention set screw here. So my guess is that nut, this bronze nut, has a central groove in it or a flat on it or something like that that engages with this set screw. And here's the bonus: is when you drive that down and close that gap, you can really control the backlash there. So Phil's like me, he's a fussy guy, right? And too much backlash there would just be like pretty annoying, right? So that's my guess. So maybe Phil will confirm that for us, my theory there. So, okay, so next one here. This is pretty cool. I have a set of these, and they are wonderful for checking holes like this, because you can fit them up into the hole and then measure directly with a micrometer instead of trying to do a transfer with a small hole gauge or a telescoping gauge or whatever. So these you can fit up in there nice and firmly. And what they are is they're tapered, and then they have a rounded edge on them, right? So that they only touch the hole at the peak of that radius there. So they're really nice, and they're easy to use. So if you can find a set of those on eBay, that's kind of a nice thing to have if you have to check a lot of holes. Checking holes, is with unless you got pins, every pin under the sun or whatever. So okay, here's a pretty cool setup here. This is kind of neat, real field expedient deal here, and so when you have a part at an angle, and you need to reference that corner, right? That theoretical corner. Maybe it's been filed off or chamfered a little bit, but what you want is that theoretical intersection of those two planes, right? One way to do that is you take a round and you make it tangent with the other surface. So with a little bit of math, you can work out exactly where that theoretical corner is, and then you can move over and poke a hole or mill a slot or whatever it is that you're going to do, and with confidence that you've actually referenced that theoretical sharp corner accurately. So that's kind of a cool field expedient way to do that. I have a little edge finder that drops over a corner like that does the same thing. But that's a cool way to do it. He's got a little magnet there, and then he just used a dowel pin, and I think he just kind of held on to it so the edge finder didn't push it off. So that's a nice little trick right there, Phil. And let's see here. What's the last one here? Okay, so yeah, so there's his vise. So he did make that vise, okay. And there's his handle, and there's another shot of that screw. And then, let's see, what was I going to talk about on this page? So you don't see these all the time. This is a Newbold Grind It. This is a guy, actually he's deceased now, but he was down in Florida, and he made some very fancy indexers, angular indexers, angular dressing tools, and these spin fixtures here. But that's not what I wanted to talk about. What I wanted to talk about was these little monkeys right here. And what those are, I believe, is for inspecting flatness. So there's a couple ways you can do that, and some specifications call for one way or some allow the other way. But in this case, what we're doing, and there's three of them. You notice that there's three of them, right? So if you have a flat plate, you spread these out and you drop the flat plate, or set the flat plate on these, and these are all very accurately the same length. And now you're supported on 3 points, so you can actually take an indicator and come up underneath and sweep that plate underneath and read the deviation. So 3 points to find a plane, right? You can read that deviation, and the requirement for this type is that they're supported on the same side, okay, as you're measuring on, right? So you have to invert everything, and that's why these are tall, so that you can get that indicator up underneath and access that whole surface. I think that's what those are. I've heard Phil talking about that before, so kind of an interesting way, or a different way of doing it. Well, not different, but just another way of doing it. So anyway, Phil, thanks for sending this along. I'm going to hang it up in the shop in 2021. Hopefully this can be a better year than 2020. And if you guys want a calendar from Phil, check out the link in the description and show Phil some love. All right, another book. And everybody knows about this book here, Machinery's Handbook. This is kind of the classic machinist text. Anyway, this one came from Urban Ore in Berkeley. I went by there and I walked through there real quick and found this. I paid $2.19 for this. So I kind of, you know, it's not like I don't have a copy of this, but this is, you know, somebody that doesn't have one, you can just hand them one with impunity and not worry about it, you know, for $2.19, right? And I see these selling for nutty money in bookstores and stuff like that, 40 bucks, you know, stuff like that. I mean, you can buy a new one for that kind of money, right? Now, this one's kind of interesting because it's, and you guys know me, right? I kind of enjoy the history and my connection with the people that have gone before me in this trade, and my connection with them through tools and books and techniques and things like that. So the kind of the history and the you know, the personal connection there. So let's crack this thing open here, and this one has I believe somewhere in the front here an inscription. And it's M. McNamara, January, and that's a 51, not a 21, which I thought it was a 21, but then that doesn't make any sense with the 12th edition. So M. McNamara, January 1951, and this is a 1945 edition, I think, is what it was. Blah, blah, blah. Yeah, right there. So Mr. McNamara, and let's see, I don't know, how do I even start this, right? Well, you know, there was some correspondence in the book, right? Okay, so I didn't see any markings or oh, what was that? Okay, I might not have seen that one. Okay, so it's just a, a piece of wax paper. That's real old-timey, old guy stuff. You know, they used to wrap their lunch in wax paper, right? And hardly anybody uses wax paper anymore. Anyway, there was some correspondence in here that made sense, right? Now, pretty sure they don't live here anymore, and but this kind of jives. This is somebody that's in their family, and this is 1967 here, and this was just in there as a bookmark, right? And it's got a canceled stamp and a whole thing with a date, which connects me with these folks here, right? And then there is this bit right here. And now all you youngsters out there probably never seen anything like this. This is carbon paper, okay? And you know, when I was a youngin', and we had to make a copy, you used carbon paper, which you could lay in between two sheets of paper, and then you could write, and the pressure would transfer carbon onto another sheet of paper, right? So you could get two copies instead of just pushing print again, right? So for those youngsters out there that can't work a dial phone, a rotary phone, that's what carbon paper is. So to kind of show my age there, right? Now, what's interesting here is this has some stuff written on it, and it has to do with Mr. McNamara. And apparently he was going through some health stuff, and this is some information from his doctor about some test results. I'm not gonna share that stuff with you, but it's on this piece of carbon paper. But apparently the tests were negative, so that was good, I guess. But right there, these two little pieces of paper with this inscription in the front kind of bring me closer to this guy. I don't know anything other than that about him. I haven't looked him up on the web or whatever. Oh, and this is San Jose, California, so that brings him into the area where this book was found, right? So this is pretty far away, but this is much closer. So anyway, kind of a little story there, a little history, I guess, and a connection with one of our workmates in the trade. So and $2.19, pretty cool, huh? I thought it was. What we got here is this is actually an interesting study in design here, and it's something I had to work on. This is part of my my Nikon optical comparator, and believe it or not, what this is here is it's a lead screw. Okay, so this adjusts the long axis. I'll just call it the x-axis on that particular machine. But what we have here is a quote unquote screw that's really just kind of devoid of any threads, right? So the way this works is in this little assembly, and we're going to take this apart so you can see the inside of this. There's a couple of bearings in here, a couple of ball bearings like this, and these are just R6 sealed bearings, no magical anything going on there. But what in fact, you can see here, they fit, rather loosely, right, on this shaft, and that's part of what makes this whole deal work. And so I'll describe the operating principle to you, and then we'll take this apart, and you can kind of see how it's set up in practice. So what they do is they actually pitch these. They pitch these at a slight angle, much the same as you would see as an infeed to a centerless grinder, for example. So they have a wheel that's kicked at a little angle that helps feed the piece through, right? Well, this little assembly here has got those bearings in it, and let's see which side moves here. Oh, it's on the screw, and this little knob, and it's a little hard to see here. Oh, okay, that came out. Look at this little edge right here, and you see that it's moving in relation to that, right? So it's got a spring inside it, and what it does is it cocks these against the shaft so that the corner of the bearing catches the edge of the shaft, and so it's kind of spring loaded. Now it's not a positive screw, so I imagine if you whacked it on the end or whatever, it would still slide, right? But for the purposes of just kind of controlled motion, it works really good. So let me take this apart, and then we'll look at the inside of this, and then what we'll do is put it back together, and I'll go put it on the machine. And actually, maybe we can even demo that right now. Okay, so it's locked up. Let's see here. I need to raise this up just a little bit so I can turn it. All right, I got to turn it. And there it goes. And then when you unlock that, now you can just kind of freewheel. So it's like a half nut kind of arrangement. So if you want to do a rapid adjustment, then you can do a rapid adjustment, and then you can just lock it down, and then now you have a fine adjustment. Man, that was actually a pretty good demo. Okay, let's take this apart and look at the innards of that. All right, so we got it. All right, so there's the innards of it. This is the little I don't know, the cam here that separates these. Okay, and so I don't know if you should be able to see this here. Is if you look at those bearings, they're in there at an angle, right? They're tipped a few degrees, and it's about 3.5 degrees, I think. I measured it when I measured it when I was reinstalling these bearings. I had to set these up at an angle like this so that I could push these kind of straight into the bore. If you lay them like this, and you're pushing them straight in, which isn't really the right way to do it, so you got to set it at a little angle there. But and in fact, the system wasn't working because the edges of these bearings were worn enough that they weren't biting the shaft properly. So once I replaced the bearings, that edge is crisp enough now that it kind of actually works. And you can actually see a little bit here. I just noticed this a little while ago. There were some marks on this shaft, and it almost looks like a thread, right? Well, there's your helix right there. So what they're doing is they're pitching these bearings at an angle to one another that creates a helix angle. And I can tell you, because the Nikon comparator has a DRO on it, that I can dial off a 1/10 on the knob without too much trouble. So it's a nice fine little screw. So why am I showing you this? Well, it's kind of an exercise in some design details, right? Here, this is all very, very inexpensive parts, right? And they've created a lead screw and a half nut system with nothing, right? With junk. So you got a smooth shaft, and you got some $6 bearings, right? I think those were $6 from McMaster, and a couple of springs, right? Okay, yeah, there's some design work. And then if you look here, we've got this cam knob here, right? And what they've done, I thought this was pretty good. So there's your travel limit, right? And it's just a roll pin, right? It's just a roll pin. So nice and simple, but very positive and cheap and easy to produce, right? And it's just holes in some anodized aluminum plates. So anyway, nice, simple little design. Nikon is pretty good with that. I've worked on some of their stuff, microscopes and comparators and things like that, and they're very good at understanding what's important about a particular design, the really critical ingredients of it, and then everything else they design for cheap manufacture, right? So they kind of get it. So anyway, so fun stuff. So let's put this back together here. And what was I just thinking about here? That goes in later. So, I guess I just wanted to mention there's a dowel pin here and a hole here, and that's the pivot point. Okay, that is the pivot point of this whole mess here. So we'll stick that together. Pop that. Okay. Okay, and then this is just a retention screw here. And it kind of keeps the whole shooting match together from falling apart on you. And what they've done is they put a thread insert in there that's a little bit snug, so what you can do is you can run this screw all the way down and not bind up the mechanism. Okay, that's all the movement we're talking about here. It isn't much, you know. And then there you can see it moving in there. Okay, and then this goes in there, and where'd my set screw go? There it goes. Little set screw. It's nice when you have all the tools already out. So that adds some spring pressure to the, let's see, am I rubbing the right end here? No, this is the end I want to move. There it goes. So now we're on the spring. It's actually pretty good spring pressure. Okay, and then Mr. Knob goes on like so. And now this, I thought this was interesting, is that the knob has an inch size, there we go, an inch size set screw in it. Okay, let's put it back together and put it on the machine. Alright, so here it is on the comparator, and it's just smooth as silk. And then if we want to release it, and then you can see that piece kind of pivot away from there, and that opens up the clearance, and now I can just slide this and kind of do a course adjustment and release, and now I'm back on the kind of phony lead screw. So anyway, it's just an interesting design to put in your bag of tricks, I guess I would call it, if you need a lead screw or you have to create a fast adjustment. And half nut arrangements can be kind of tricky to do because the thread depth is so deep. You have to actually release from the thread, so the distance that you have to move is considerably larger than this. So this is pretty small movement. I don't know, I just think it's cool. Hope you do too.